Hi YouTube, it's Joe here, and first thing I like to say is thanks to all my subscribers. We're up almost to 600 now, so that's a good thing. Thank you very much. Today I pulled out my old toaster oven here. You may have seen this in the shop. I originally brought this out here when I did the spindle bearings in my lathe, and I needed to heat them up. I got some dry ice and I cooled down the spindle, and then I heated up the new bearings with this thing and dropped them on back before the days of YouTube. But anyways, I really haven't been using this thing much, but I have quite a bit of this tool steel that I picked up at a garage sale, and you know, it has the hardening and temperature profiles right on the package. So I figured, why not make use of this stuff? You know, you can harden it by just you know, using an acetylene torch, and you know, you heat it up till it's non-magnetic. You let it sit there for a while, which is a pretty bright, you know, almost a yellow color. And this stuff, I have air hardening, but this stuff is oil hardening. And you know, you quench it in the oil, and then it's glass hard. So you have to temper it, and typically with this kind of stuff you temper it at like 400, 450, something around there. You know, you let it sit there for like an hour, and it tempers up. So what I figured is I'd use this oven. It goes up to 500 just with this little thermostat controller thing here. But what I did is I went out and I bought a temperature controller. And this, you know, these are all over Amazon and eBay. They're like 20 bucks. This particular box contains three things. It contains the controller itself, a K-type thermocouple, and a 40 amp solid state relay. So with all of this stuff, you can turn this thing into a tempering oven. So let's see what's inside of this thing. I opened it up, but I haven't taken anything out of it yet. Instructions, which is a good thing. This came off of Amazon. Some kind of bracket to hold it in. Inkbird solid state relay. We'll see how long that lasts. A screw-in thermocouple. And here's the little controller module. So that's a PID controller. It's auto tuning. And what the plan I had was to install it, you know, take this stuff out of here and install it in here. And there ought to be enough room inside to hook this thing up to, you know, a metal surface to keep it from melting down. We'll figure out a place to screw that in so it senses the temperature. I don't know if we'll make use of that or not. So anyways, yeah, quick little project, a little wiring, a little machining, and we'll have ourselves a temperature controlled tempering oven for tool steel. So stick with me, it ought to be fun. Okay, so I don't know if you can see this, but they got these little triangle screws in here. I've never seen anything like that before. What I did is I ground up a screwdriver that'll kind of fit in their caddy corner and get them out. Come on, baby. As usual, there's like 40 of them in this thing. Probably end up replacing these things with regular Phillips head. Alright. We got them all. Alright. Wondering if these knobs just pry off of here. Like glued on there or something. We'll have to see about that. Get some wire cutters. Looks like it's going to be pretty easy to modify. It's got spade lugs on everything, which is good. One more. Looks like you glued that one in. Alright. You really don't want us to get into this part of it, I guess. Yeah, they glued it in here. Alright. Alright, we got the necessary pieces off here. Probably get rid of a lot of this wiring too, because I'm not using all that other stuff. Alright. Looks like there's two heating elements in here, and I guess what we're going to do is put them both in parallel so they heat up at the same time. Alright, let's figure out how we're going to modify this thing. Okay, so what I did here is I hammered this flat, and then I laid out a square, 45mm square, and I'm going to just cut that out. Okay, so with a little tin snipping and filing, we got this thing to fit in here just like so. And there's a little clippy thing you put on here, but I'm not going to put it on yet because we still got to wire this, so but that's how it's going to look. We're going to just have this one controller right in there, just like that. Alright, so we'll wire this thing up now. Alright, we get this thing wired up, so I guess the only thing left to do now is plug it in. Should be like massive fire here. Crap. Look, it's heating up. Alright. So that's good. We'll put this thing on here. And button it up, and then we'll see about programming some things here. But yeah, man, that was pretty neat. No fire came up. It's a good thing. Alright. Okay, so what this thing is doing right now is going through an auto tune cycle, and that's supposedly going to calibrate this whole thing. Yeah, these menus are a little cryptic, but I think I pretty much have this thing going. Most hobby machinists can't afford to buy brand new expensive stuff. So if you're lucky, you find things like estate sales and auctions and things like that. And I was fortunate enough to find one many years ago. Got a ton of end mills, got parallels, got all sorts of stuff for real short money. People who watch some of my older videos might remember that I got a bandsaw blade welder, I got a tool grinder, a tool bit grinder, all sorts of stuff. And one of the things I got was in this little Starrett box. And I never knew what this was until I found a channel on YouTube where a guy was using them. And the guy's channel is Tom's Toolbox, or maybe Tom's Tool Room. I'll have to check, but I'll put the link. And he doesn't have too many videos up there, but he showed me what these are for, and now I'm going to show you what they are. They're pretty neat. They are Starrett number 54s. Still in the box, and they're called hold downs, and they do something really neat. So anyways, I'm going to go over to the vise here and I'm going to show you how these work. Okay, so here we are over at the mill, and it's a close-up of what these things look like. And the notable feature here is that they're not 90 degrees. There's a slight angle on them. So let me show you what that is useful for. In these cheapo vices, the problem is the back jaw tends to lift up when you apply torque to it. The reason for that is that the screw that draws the jaw in off the handle is below the jaw. So naturally, like when you start applying force, it's going to want to lift the back jaw up. So what do you do about that? You take your piece of stuff here, you put it on the parallels, you put some torque on it, and what happens? It's up off the parallel. So you whack it with a hammer, and then you tighten it up a little more, and you can do it that way. But what this little thing does is it eliminates that that lifting, because of the fact that it is not a 90-degree square here. When you tighten up the jar against it, it'll tend to force down on the part. So what you do is you put your part in here like this. You put this parallel in here. You square it up on the back jaw. You lift it up. Okay. And you can see how it's camming down when I apply force. And now this parallel is in there tight. It just saves you the trouble of whacking the crap out of it. Okay, I wanted to share with you a little trick here. I had to lay out a couple of holes on a known bolt circle, so it's easy to do on the lathe, right? I came back and I found the center. Alright, then I moved out to my bolt circle and I rotated this by hand and made a little mark, and then I just drew two lines with the thing this way. Oop, we're hitting the camera here. But anyway, that's a quick and easy way. If you got to lay out, you know, a couple of holes, you get the precision of your lathe, and you don't really have to measure anything. You can read it right off the dials. All right. Hi guys. Well, you may remember, like in one of my previous videos, I modified this light that I bought off of Amazon for a machine light, and since I made them, I made 3 of them. One of them has failed, and the actual LED failed. So, you know, I was going to replace this, but it's pretty much impossible to get the LED off of there because of the way they thermally bonded on there. So what I've decided to do is to use an AC operated supply here. And what this is it runs off of the 110. Actually, I think this thing is universal input. 88 to 260. I can't hardly read it, but in any case, this thing, you plug it into the mains, and then this drives the LED out here, and it's a constant current supply specifically designed for this 10-watt LED. And the advantage of this thing is there are 9 individual LEDs in an array, and you know, it's got a much bigger heatsink area on the back. So what I'm going to do here, first let me show you how crazy this thing is. I'm running this off a bench supply, and they start turning on. That's about 7 volts right there, and you can see the little LEDs in there. But if I crank this baby up to like 12, well, it's current limiting right now at 8 volts, but this is insanely bright. So the way I'm going to do this is I'm going to machine this out of a piece of 2.5-inch bar stock, and then just directly mount the LED right in there. And this part will be remote from the light. You know, it'll have a plug on it, and then wires, low voltage wiring, will go up to the light. So anyways, let's see what happens here when we make machine lights Rev B. Alright, we're just doing a little test here. I have some heatsink compound underneath this LED. She's hooked up to the driver. I made some measurements. It's running at 9.6 volts at 900 milliamps, which, you know, is not 10 watts, but it's getting there. So we're going to do a little flicker test here to see how it does on the camera. And I must say that that looks really good. So they're obviously filtering this. This is throwing off a tremendous amount of light. I can't even look at it. Alright. I can only imagine, you know, these things, they come 10 watts, 20 watts, 30 watts, 50 watts, and 100 watts. This is a 10 watt chip and a 10 watt converter. And, you know, I picked this because I'm like, well, you know, if you want the light to be reasonable in size, you know, I mean, you got to be able to dissipate the heat in it. And 10 watts is plenty of light, and, you know, for a machine light application, but it's not an unmanageable amount of heat. I can only imagine what the 100 watt LED would. I mean, that thing would be like looking at the sun. But I do have. Where is that thing? You know, it's always hanging around until you need to find it. Oh, here it is. Now this is a CPU heatsink cooler. Right now I got it just cooling a bunch of MOSFETs, but I think you would need something like this to run a 100 watt one, and that would, you know, that'd be something like an outdoor spotlight or something like that. So anyways, yep, this is the 10 watt version, and it looks like it's going to be just about perfect for what I have in mind for this thing. So I think the first one I'll do is I'll just build it up inside of this thing. Okay, so here's the final product here. Got this LED chip in here, and it lights stuff up pretty good. So we'll let that percolate for a while. Actually, it's been on there for about a month. As you probably can tell, these videos on this Doodads are a little out of sequence. But got it in there, and it's working good. And, you know, we'll see what happens, and we'll make some more of these things. Okay. Well, that's it. Thanks for watching. And again, thanks for all the subscriptions. And click the like button if you like these videos. And let me know if you don't by clicking the don't like button. Later.